For a long time, the Milky Way looked familiar. A vast collection of stars moving through space in patterns that seemed stable enough to map and understand. Then, in 2018, astronomers began sorting through data from Gaia. Instead of a neat picture, they found something unsettling. A huge population of stars was moving through the galaxy in ways that did not fit the structure researchers expected to see. On the map, the stars were still there, but their motions were wrong. Some traveled through the Milky Way on paths that seemed disconnected from the history the galaxy was supposed to have. The more of these stars that appeared, the harder it became to dismiss them as isolated oddities. That created an immediate problem. If large numbers of stars are moving in ways that do not belong inside the accepted picture, then the picture itself becomes harder to trust. The Milky Way no longer looks like a place where every star naturally belongs where it is. Instead, the galaxy begins to look like the scene of something much older, something massive, and whatever happened may not be gone. The evidence may still be moving around us today. The easiest explanation still had one advantage. Maybe the strange motions were not real. Maybe the measurements were incomplete. Maybe the data contained errors. Maybe a few unusual stars were creating a pattern that only looked important from a distance. Then Gaia kept measuring. The catalog grew larger, and the precision improved. Instead of fading, the pattern spread. The same unusual motions appeared again and again across enormous regions of the Milky Way. What first looked like isolated exceptions began showing up in vast numbers. That changed the situation immediately. A measurement error can disappear when better data arrives. A local anomaly can remain confined to one area. But this behavior was doing neither. Every improvement that should have weakened the signal was making it harder to ignore. The stars were not drifting back into the expected picture. They were continuing to move together in ways that did not match the populations astronomers expected to find. One by one, the simple explanations began to disappear. The problem was no longer a handful of unusual stars. The problem was a huge population that appeared to share something in common. Whatever was being seen, it was not random. And if these stars truly belonged to the same larger pattern, then something had placed enormous numbers of them inside the Milky Way while leaving them fundamentally different from the stars around them. The pattern was no longer random, so attention shifted to the stars themselves. Researchers began comparing them in different ways, not just where they were moving, but how old they appeared to be, what chemical signatures they carried, and how they traveled through the galaxy. A new pattern emerged. Many of these stars seemed to belong together. They shared similar ages. They shared similar chemical compositions. They followed orbital paths that looked related rather than accidental. That changed the shape of the problem. Instead of countless unrelated anomalies scattered across the Milky Way, the observations began to resemble a single historical population, leaving traces across the galaxy. For the first time, a more comfortable explanation became possible. Maybe these stars did not require anything external at all. Maybe they were remnants of an unusual chapter from the Milky Way's own past. The strange motions would still be real. The unusual chemistry would still be real. But the mystery could remain inside the galaxy rather than outside it. That possibility restored a sense of order. The Milky Way no longer appeared to be hiding an unknown intruder. It might simply be preserving evidence from one of its own earlier eras. And if that explanation was correct, the deeper details should continue pointing back to the Milky Way itself. Then, the details became harder to explain away. Researchers kept comparing the stars, expecting the Milky Way's own history to keep providing the answer. Instead, the evidence began pulling in a different direction. The stars did not just share similar ages and motions. Their chemical signatures lined up in ways that matched an external dwarf galaxy far better than the native populations expected inside the Milky Way. The more measurements were compared, the more the same pattern appeared. Different observations pointed toward the same destination. The stars looked connected, but they did not look local. That created a direct conflict with the explanation that had briefly restored order. If these stars formed inside the Milky Way, their chemistry and orbital behavior should resemble the galaxy that produced them. Instead, they behaved like a population that originated somewhere else entirely. The internal history explanation began to fail. What had looked like an unusual chapter of the Milky Way's past now looked like evidence left behind by something foreign. A new picture started taking shape. Long ago, another galaxy entered the Milky Way. Gravity pulled it apart. Its structure disappeared. Its identity vanished. But its stars survived. They continued moving through the larger galaxy, carrying the orbital patterns and chemical fingerprints of the place where they originally formed. The strange motions were no longer a mystery waiting to be explained. They were wreckage, evidence left behind by something that no longer existed. The Milky Way was not simply preserving its own history. It was carrying the remains of a destroyed galaxy inside itself, and that created a much larger problem. If an entire galaxy had been torn apart inside the Milky Way, then many of the stars visible today were never truly part of the galaxy that appears to contain them. The collision is long over. The smaller galaxy is gone. Its structure no longer exists as a separate place in the universe. Yet its stars remain. They still orbit inside the Milky Way today, mixed among billions of others, carrying evidence of an event that reshaped the galaxy itself. That changes what the Milky Way actually is. The familiar spiral stretching across the night sky no longer appears to be the product of a single uninterrupted history. The merger was not a brief disturbance that passed without consequence. It helped create the galaxy that followed. Large populations of stars now moving through the Milky Way appear to be survivors of that destruction, continuing their journeys billions of years after the original galaxy disappeared. The collision is gone. The smaller galaxy is gone. Yet its stars are still here, moving through the Milky Way as if they belong. What once looked like a single galaxy now appears to be a reconstruction built from survivors. Some of the stars that seem most at home in the Milky Way were never born here at all.